Hi, my name is Meenu Gaba. I'm an engineering lead on the machine learning team here at Google. I'm really excited to share what's new in machine learning for Google developers. We'll be going through the ecosystem of tools and APIs for developers who want to train and use machine learning models. The machine learning world has completely changed since we open sourced TensorFlow in 2015. Back then, we counted TensorFlow users by looking at citations in academia. It is incredible to see how far AI has come, improving the lives of everyone. Take a look at AlphaFold, developed out of DeepMind that uses AI to predict a protein's 3D structure. But what's even more exciting is how AI is becoming common in our day-to-day lives. And you don't need to be a machine learning expert to harness the power of AI. Take SimpleML, the Google Sheets add-on, that enables anyone to predict missing values or spot anomalies in their data, applying the power of machine learning with just a few clicks. And then there is BART, an early Google experiment that lets you collaborate directly with generative AI, and it is based on some of our large language models. I bet you are excited to learn more about generative AI, so be sure to check out our session, What's New with Generative AI. You can find a link in the description below. Our mission is to enable every developer to improve their products using machine learning. From free and open source frameworks like Keras and TensorFlow, to development tools like Colab, to resources like Kaggle, all while ensuring responsible AI principles. We use machine learning extensively at Google, from internal systems that help prevent food waste to products with billions of users like Search and YouTube. But when I say machine learning, it's not just about numeric computation. It is the whole development lifecycle. From data to creating and training models to deployment and operations, with support for seamless hardware acceleration and guidance to help you deliver the most responsible experience. We believe that it's time for AI and machine learning to be part of every developer's toolbox. Let's dive right in to learn more. We'll start with data. Data is the lifeblood of any machine learning application. Without it, there is no way you can train a model to infer. It would be like teaching a child to recognize different animals without sharing any relevant information, like animal sounds, pictures, videos, or smells. And to help you manage your data, we've got lots of new and exciting updates. Let's start with Kaggle. Kaggle is a machine learning community of over 13 million users who have shared over 200,000 public datasets to get you started. Of course, simply having a good dataset isn't enough. You'll need to prepare your data to be able to train your model. This can be as simple as sorting, slicing, and shuffling data, which you can do with TensorFlow datasets, a collection of public datasets that's ready to be used with TensorFlow or any other Python ML framework like JAX. But there's another key to preparing your data, and that's data augmentation, which allows you to effectively expand your datasets for new scenarios by augmenting data that you already have. Let's imagine you're training a model to recognize horses, but all of your pictures of horses are oriented facing left. Your model won't recognize a horse that looks like this, facing right. But if you augment your dataset to randomly flip some of your training images, now it'll be trained to recognize these horses too. And of course, data augmentation isn't just about flipping. There are so many ways you can effectively expand a dataset. With Keras CV for computer vision, this is easy. With simple high-level APIs that become part of your default workflow, you will be augmenting your data in no time. Here is an example of RandAugment that applies a wide range of random visual transformations. And let's look at the results. This is just a quick snippet of the tools available to you for gathering and managing machine learning data. To discover more tools and the latest news from I/O, please visit us at ai.google/machine learning. Now that your data is ready, let's start on the next step, training a machine learning model. We have learned that needs of production and cutting-edge research are often different, that a single universal framework does not work. From TensorFlow and Keras to JAX, you have a lot of choices when it comes to frameworks to train models. I'm going to dig into what's new for each of these. Let's start with Keras. Keras is built on top of TensorFlow, providing you a high productivity API for defining many types of models with tools that simplify your workflow like data augmentation. Earlier, we showed you how Keras CV can be used in your workflow to augment your data, but it can also help you with image classification, a classic computer vision challenge. With Keras CV, you can take code like this and simply pick an existing model to use as backbone, and then define the number of classes you want to identify, and train the model on your data, and use it. Keras CV can also help you with object detection. So picking out objects in images and putting a bounding box around them has never been easier. These are tasks that would have been hundreds of lines of code or more not that long ago. But look at it now. Let's talk about language modeling using Keras NLP or Keras Natural Language Processing. Transformer-based models like BERT and GPT are popular these days, and Keras NLP makes it easy to get started. For example, we can quickly make a BERT-based text classifier to analyze sentiment from movie reviews. With just a few lines of code, we construct our model, and a few more lines of code to infer negative and positive sentiment. Language models like these are being applied in more and more contexts, whether it is on the cloud or a device in your pocket. But what if you want a smaller model for an embedded device? You can do that end-to-end with Keras NLP and TensorFlow Lite. Let's take the text from a newspaper dataset and use it to fine-tune a GPT-2-based model open sourced by OpenAI. And just with a few lines of code, the model is generating new text. This small model is still pretty powerful, and we are helping you run it on Android. We have open sourced the code for this autocomplete example, so you can build your own. I've only just scratched the surface of how Keras can help you on your machine learning journey. So check out the session, Applied ML with Keras CV and Keras NLP to dive deeper. You can find the link in the description below. Let's go back to TensorFlow, which Keras is built on top of. TensorFlow has a powerful ecosystem that meets the needs of applied machine learning developers. Engineers who need to build and deploy reliable, stable, performant ML systems at any scale and on any platform. I'm going to share some new updates on how we are continuing to make the framework faster and more powerful than ever. On one hand, models are getting bigger and bigger. To help you scale, dTensor lets you parallelize both your data and model, splitting work across multiple machines. And on the other hand, machine learning is also being used in embedded devices and phones, where you need to optimize for resource constraints. The new TensorFlow quantization API lets you adjust your model size easily. The last framework I want to talk about is JAX. It's a popular choice for researchers who train very large-scale models, and the framework that Google Research uses to develop breakthrough and language diffusion models. All these frameworks have great use cases, which is why we are excited to bring these frameworks together. In particular, JAX to TF lets developer take models in JAX and extend them to the TensorFlow ecosystem, deploying models into production with ease. Now, of course, when creating models, you don't always need to start from scratch. As I showed you earlier, with the text generation example, you can start from an existing model and fine-tune it. To help you find those models, we are pleased to announce Kaggle models, where you can search for hundreds of trained, ready to deploy, ready to reuse models all in one place. You can get the complete model, all the source code, and the data used to train it. And it's not limited to just simple models. Here is a model from a Google research paper that demonstrates how to synthesize audio from a spectrograph. More models are coming online all the time, and we can't wait to see what you will discover and use. Now that you have gathered your data and trained your model, you need to run it somewhere. Fortunately, when you are in the Google ecosystem, you can deploy your models just about anywhere compute capacity is available. From the tiniest microcontrollers or embedded devices, to hand and mobile devices on Android or iOS, to the browser, including that on future phones, to the backend, from the smallest simple shared web server all the way up to global scale cloud and beyond, where you can blend any combination of these. Let's start with the browser. With TensorFlow.js, you can train and use models directly from the browser with no additional install. And with Chrome supporting Web GPU, This opens up a whole slew of new opportunities for machine learning developers in the browser, such as using diffusion models without needing an expensive backend. Just use your local GPU. Or Adobe, using machine learning in browsers to make photo editing easier. Or the visual blocks for ML tool that allows you to create machine learning pipelines directly in the browser. Let's switch over to Android devices, where the team has been hard at work making machine learning easier and more powerful. To start with, TensorFlow Lite ships as part of Google Play services, so you don't need to ship TF Lite runtime yourself. For example, Stripe reduced their app size by over a megabyte, and to date, over 10,000 apps have taken advantage of this to reduce their binary size. Then there is hardware acceleration via delegates. When your device has hardware such as the Tensor chip on Pixel, TensorFlow Lite can access this processing power for faster and more battery-friendly inference. And now in public beta is the Android Acceleration Service, a new API that helps you identify the optimal hardware acceleration configuration for your model at runtime. One question we do get from our developers is how can they integrate machine learning models into their applications more easily? Well, we are working on that. I'm going to hand it off to Chuo-Ling to tell you about MediaPipe, that is part of our low-code solution.
Hi, I'm Chuo-Ling. I lead MediaPipe at Google, and I'm here to talk about how MediaPipe makes it easy to incorporate machine learning into your on-device applications. Now you may be wondering, isn't it just about finding or training a suitable ML model, and you then simply run model inference in the app with the right input and output application connected? Not quite. There's often more to it. First, model inference, say, by a TensorFlow Lite, typically expects input and output in the form of tensors. However, application data are generally not tensors. For instance, an image processing application on Android may have its input and output represented as bitmaps. Therefore, additional data format conversion steps are usually needed. Beyond format conversion, there are often additional pre- and post-processing steps. For instance, in audio applications, you may want to transform audio signals into spectrograms before feeding them into the ML model. It's also common to require a cascade of multiple ML models, say running a detector model to first localize a dog, followed by a classifier to identify its breed. There are also cases where you will want to run two models in parallel, and then merge and feed their outputs into a third one. Or sometimes introduce data flow that skips some parts of the pipeline, or even introduce a feedback loop. As a result, these ML application pipelines can quickly become rather challenging to develop. On top of all that, for best on-device performance, the pipeline implementation often requires platform-specific optimization. This means you will have to implement and optimize one for each target platform, such as Android, iOS, web, and so on. This is where MediaPipe Tasks comes in to help. It's an extensive collection of cross-platform APIs that encapsulate all those complexities for common on-device ML tasks. For example, object detection in the vision domain, text search in natural language processing, and audio classification in the audio domain. With any task API, you can plug in your own model if you've trained one compatible with the task, or simply pick one of the building models provided with the task. For example, the image segmentation task comes with a building model for multi-class segmentation, as shown here, and it can be incorporated into your application with only a few lines of code. Let's look at a sample code snippet in Kotlin for Android apps. First, you create an image segmenter with some configuration options you get to specify. Then you prepare the input image, in this particular example, from an Android bitmap. After that, you run the task and get the segmentation masks. It's as simple as that. And again, in addition to the Android API, MediaPipe Tasks also comes with iOS, JavaScript, C++, and Python APIs, and we will be adding even more platform support down the road. Let me show you more examples of the new tasks we just released at Google I/O. Here, I'm showing you the interactive segmentation task that lets users pick the object or area of interest interactively. Note how users can easily refine the segmentation to their liking with just simple scribbles and get the segmentation propagated throughout the video in real time. In this example, I'm showing you a task that in real time generates plane shape coefficients that represent facial expressions to use in applications such as driving an avatar. As another example, the face stylization task lets users generate stylized portrait images entirely on-device based on a given reference style. There's also a gesture recognition task, which comes with building models for recognizing single hand gestures like thumbs up and two-hand gestures like timeout. All these MediaPipe tasks are powered by the same underlying MediaPipe technology that's also powering many of the Google applications you are familiar with, including Google Meet, YouTube, Photos, and many more. Let's take another look at the gesture recognition task. While it is great to be able to recognize these building gestures, what if you need gestures that are not yet supported, say for building a game of rock, paper, scissors? This is where MediaPipe Model Maker comes in to enable further customization. With MediaPipe Model Maker, you start by following its instructions to prepare your own dataset. Then you just run a few lines of Python code. First, load the dataset you prepared, followed by a simple function call to start training custom models, followed by evaluation, and finally export the trained models as an asset bundle. You can then plug the bundle back into the corresponding gesture recognition task, and here you go with the game of rock, paper, scissors. We are also releasing MediaPipe Studio, a web-based playground for you to try out MediaPipe tasks interactively, with all the machine learning running locally on device within the web browser. Finally, to share the recent progress we've made around on-device generative AI, we are releasing a sample app that performs diffusion-based text-to-image generation on Android, like the example shown here, entirely on-device in as fast as a few seconds. To learn more about MediaPipe, please visit developers.google.com/MediaPipe and our open source code repo. We also have an I/O Tech Talk on easy on-device ML with MediaPipe and a workshop on supercharge your web app with machine learning and MediaPipe. Please check them out. Now I'll turn it over to my colleague to share the latest on ML operations.
Hello, my name is Dwarak Rajagopal, and I lead some of our machine learning engineering efforts here at Google. When your goal is to use ML in products or services, you need processes and systems for repeatability, scalability, tracking, explainability, basically all the things you need for any production deployment. You need MLOps. To enable developers to create robust, reliable, and repeatable pipelines, we introduced TensorFlow Extended, or TFX for short. It's a Google-scale framework of libraries and components that's used by our major teams in ads, search, YouTube, and maps. And other companies, including Spotify and Airbus, use TFX as an end-to-end machine learning solution for its stability in production. TFX comes with a full set of standard components to get you started, but it's not just for TensorFlow. You can write custom TFX components to customize your ML pipelines for models on JAX, XGBoost, scikit-learn, and even PyTorch. Data governance is important for large models and production applications. TFX also includes an ML metadata library for recording and retrieving data at each step to create and track data lineage. This helps debug issues in the event of unexpected pipeline behavior and how the team at Vodafone used TensorFlow data validation in their data contracts to advance their data governance. TFX is also a great choice for developing generative AI and can be integrated with many other open source tools across a growing number of verticals. TickDigits, who shared how they use TFX to develop models and tooling to make accountants more productive. And of course, TFX is an open source project with many community-built add-ons. If you would like to start contributing, we would like you to be sure to join the TFX add-on group. Accelerated infrastructure for training and running models in production underpins AI readiness. Let's start with the excitement around large language models. And as their name suggests, they are large, often huge. These cutting-edge AI models are also more complex because of the size, increasing compute requirements. Not only does the expense incurred increase, getting access to the sufficient compute is challenging. This necessitates the need for model optimization and compression. Just like there are many frameworks to support your needs, we also want to provide you with a choice in which infrastructure you use for training and model deployment. And to that end, we are delighted to give an update on OpenXLA. If you are not familiar with it, XLA, or Accelerated Linear Algebra, is a process that compiles machine learning operations to optimize them for a particular piece of hardware such as TPU or GPU. It allows you to squeeze the best performance out of your models in a unified compiler and runtime stack, so you can migrate workloads seamlessly across hardware. As machine learning grows, we must also consider what is arguably the most important part of the entire ecosystem, which is building responsible AI solutions for everyone. Put simply, our goal is to not only provide you with tools to build AI solutions, but to do it reliably and safely. We've been working and leading the world with tools and resources for responsible AI. And with all the interest in large language models, I would like to call out latest work we've been doing to make building language models safer. It's the principles on which we built our own models. You can find more by viewing our session, Safe and Responsible Development with Generative Language Models. We'll put together a link to the description below. We care deeply about building AI responsibly, but also recognize the ML ecosystem is new and evolving fast. We are continuing our ongoing commitment to research in this arena and will continue to partner with you to ensure that together we build a responsible and safe AI for everyone. We've covered a lot of territory today. I hope this has shown you the breadth of tools that are available for you to build for AI. Our goal is to make AI easier for everyone, so I'll leave you with some of the additional links to some great video stories of how developers are using AI to solve real-world problems. Thanks, and we'll see you next year.